Now sometimes people wonder what causes sometimes the waves to form constructive, some form destructive interference, right? So one of the factors that can determine whether the waves will form constructive or destructive interference is what we call as path difference. So what is path difference? Path difference is the extra distance that one wave has to travel compared to the other wave. For example, if you look at these two slits here, and we look at the point P where they meet. So we take a point P where they meet, right? So which wave will travel further, from S2 or from S1 will travel further before reaching P? From S1 will travel further, right now, because it's a further distance, right now.
Yeah.
So the extra distance here that it travels compared to your S1 will be called your path difference. So this part is called the path difference. Alright, so the path difference will determine your phase difference, because you see whenever they meet and they form constructive or destructive interference, it depends on the phase difference when they meet. If they meet in phase, you get constructive. If they meet out of phase, 180 degrees out of phase, which is also called anti-phase, you get destructive. So let's see what happens when they travel different distances. Now let's say the wave coming in from S2 reaches first. Let's say the wave from S2 reaches first. This is at point P. At point P, it reaches already. Now the wave from S1 has to travel an extra distance, right? Now let's say the extra distance that they travel here is equivalent to one wavelength. Alright, let's say it's equivalent to one wavelength. So after the wave from S2 reach already, so after one wavelength, that means after one wavelength here, because S2 reach already, but it continues after one wavelength, then S1 comes in. So when it comes in at P, it will look something like this. Right now?
Yeah.
So this is when the path difference is equivalent to one wavelength. So if at the point where they start to meet here, will you get constructive or destructive? Constructive. But if let's say the point P we take somewhere further, let's say he take here. So now the path difference is even bigger. So now let's say the path difference is now equivalent to two wavelengths. So that means instead of coming in here, the wave S1 travels two wavelengths extra, then only comes in. Alright, so now the path difference is equivalent to two wavelengths. But the moment they meet here, you form constructive or destructive? Constructive interference. So the conclusion is, if your path difference is equals to one wavelength, two wavelengths, three wavelengths, and so forth, you will definitely get constructive interference. Understand? Okay? Now let's say the path difference is different. Okay, now let's say we start off like this. So let's say the wave from S2 reaches already, and the wave from S1 travels an extra distance of just half a wavelength, just a small path difference, equivalent to only half a wavelength. Then it comes in. So when they start to meet at P, will it be constructive or destructive? Destructive. And if let's say we take a point further away here, and the path difference is bigger, and let's say now the path difference is equivalent to 1.5 wavelengths here, so which is 3 lambda over 2. So then when it comes in at this point and meets with the wave from S2, will you get constructive or destructive? Destructive as well. So conclusion is, if the path difference is equals to half 3 lambda over 2, 5 lambda over 2, and so forth, you will get destructive interference. That's the rule. So how do I know what is the path difference? Alright, so how do I calculate if let's say I want to know whether it's constructive or destructive? Now, example, if they tell me that S2P, which is from here to here, is equals to 3 meters. Okay? And S1P, if let's say is 5 meters. So what is my path difference? 2 meters. So in order to determine whether you're constructive or destructive, you need to see in terms of how many wavelengths. So how to get how many wavelengths? Now, let's say the lambda which I give to you is 4 meters. So you need to express the path difference in terms of how many wavelengths, how many fractions of wavelengths. So you take the path difference, which is 2 meters, you divide by your wavelength 4 meters, and you put a lambda there straight away. That's the fastest way to find the path difference in terms of lambda. You just put the wavelength and put a lambda in front. So you get half a wavelength. So that means at P, will it be constructive or destructive? Destructive. That's how you know. But if they ask you for the phase difference when they meet, then you will convert to degrees or radians. So if lambda over 2, then it's 180 degrees or pi radians. You understand?
Yeah.
Right. Let's look at. So let's look at the actual pattern when you use Young's double slit experiment. So let's say this is your double slit, okay, and let's say this is your light source, okay, with a color filter. So what will you see on the screen? Now in the middle, you will always get a bright fringe. So let's say I'm using red color, red light. So the middle, I will get red light. This whole thing will be red. So why do you get a bright fringe in the middle? Because can you see that the path difference is 0 because it travels equal distances? Correct or not? So some people ask me, is path difference the same as phase difference? I said it is not. You see, phase difference is a fraction of a cycle by which one wave leads or lags the other. That means one wave reaches first, one wave reaches later. So what can cause phase difference? Path difference. If one wave starts later, one wave starts earlier, that's called phase difference at the source. But if both start together, but one wave travel further, one wave travel shorter, then there's also a phase difference. So let's say both of us have the same speed, we run. But if let's say I have to run a further distance, when we reach the finishing line, definitely you'll be ahead of me, right now. So at the finishing line, you are ahead of me because that means we say there's a phase difference between both of us, but it is due to path difference. Can you see that?
Yeah.
But phase difference can also be caused by phase difference within the source. Now, let's say we travel same distance, but you cheated, you started first. Then I see you running, then you start running. So definitely, even though we have same speed, but when we reach, you're ahead of me, because that means there's a phase difference at the point where we meet, but not because of path difference, but because there's a phase difference at the source. So you must understand that path difference is a cause of phase difference. Understand that? All right. So let's talk about the other bright fringes. Sorry, I used red. Use red. So the next few fringes. Okay, let's look at what is actually happening. Okay. Now, when you see the next bright fringe, which is here and here, this is called first order. So how will I label? I will label this as first order, 0 order, first order, second order, second order. They're always symmetrical one. And the first order bright image, which is here, is formed when? When the path difference is equals to lambda. That means this wave travels a shorter distance, this wave travels a further distance by extra lambda. Therefore, they get the first constructive interference. So what about this? Why is there a dark fringe? Because here, the path difference is lambda over 2. So then the next dark fringe, this is when the path difference is 3 lambda over 2. And the next bright fringe is when the path difference equals to 2 lambda. So the first order is when path difference is lambda, second order when path difference is 2 lambda, third order is when path difference is 3 lambda. And it's exactly symmetrical on the other side as well. So that means here the path difference is 0, so I better write down here. Here path difference is 0 in the middle. But then after that it's symmetrical. So here path difference will be lambda over 2, lambda, 3 lambda over 2, 2 lambda. Understand? So that's how you get a pattern.